Cuban underwater structures, sunken megaliths of Caribbean. Beneath the crystal-clear waters of the Caribbean Sea, off the northern coast of Cuba, lies a mystery that has captivated scientists, archaeologists, and explorers for decades. A vast network of sunken megalithic structures that challenge our understanding of ancient civilizations and their capabilities. These underwater formations, first discovered in the early 2000s, have sparked intense debate. Are they the remains of a lost, advanced civilization that once thrived in the Caribbean? Or are they merely natural geological formations shaped by millions of years of oceanic forces? The answer to this question has the potential to rewrite the history of the Americas, shedding light on a chapter of human history that has long been buried beneath the waves. To truly understand the significance of these Cuban underwater structures, we must delve into their discovery, examine the evidence for both man-made and natural origins, explore the theories that surround them, and consider their implications for our understanding of ancient human societies. This exploration takes us on a journey through the depths of the Caribbean, through the annals of archaeological history, and into the realm of scientific inquiry, as we seek to uncover the truth behind these enigmatic sunken megaliths. The story of the Cuban underwater structures begins in the year 2000, when a team of Canadian and Cuban researchers, led by marine geologist Paulina Zalitsky and her husband Paul Weinsweg, embarked on a sonar mapping expedition of the sea floor off the western coast of Cuba, near the Guanahacabibes Peninsula. The team, working aboard the research vessel Ulysses, was initially tasked with conducting a survey of the area's marine life and geological features. As part of a joint project between the Cuban government and the Canadian company Advanced Digital Communications, ADC. What they discovered, however, was far beyond what anyone had anticipated. As the sonar equipment scanned the ocean floor at a depth of approximately 600 meters, 1,968 feet, it revealed a series of unusual geometric formations that stood out sharply against the surrounding natural terrain. The structures appeared to be arranged in a grid-like pattern, with straight lines, right angles, and rectangular shapes, features that are highly unusual in natural geological formations. The sonar images showed large, flat platforms, circular structures, and what appeared to be walls or columns, all made of dense, dark stone that contrasted with the lighter sediment of the sea floor. Zalitsky and her team were stunned by the discovery. They had stumbled upon something that seemed to defy explanation, something that hinted at the possibility of an ancient, sunken civilization. In the years following the initial discovery, the team returned to the site multiple times, using more advanced technology to map and document the structures in greater detail. They employed side-scan sonar, which provides high-resolution images of the sea floor, as well as remotely operated vehicles, ROVs, equipped with cameras and sampling tools to get a closer look at the formations. The ROV footage revealed even more intriguing details. Large, smooth blocks of stone, some measuring up to 10 meters, 33 feet in length, arranged in precise patterns. Some of the blocks appeared to be stacked or aligned in ways that suggested human intervention, with edges that were too straight and angles that were too perfect to be the result of natural processes. The team also found evidence of what seemed to be channels or pathways between the structures, leading some to speculate that the site was once a coastal city or ceremonial center that had been submerged by rising sea levels. As word of the discovery spread, the Cuban underwater structures quickly gained international attention, attracting the interest of archaeologists, historians, geologists, and even conspiracy theorists, all eager to uncover the secrets of these sunken megaliths. One of the most striking aspects of the Cuban underwater structures is their sheer scale and complexity. The site covers an area of approximately 2 square kilometers, 0.77 square miles, making it one of the largest underwater formations ever discovered in the Caribbean. The megaliths themselves are composed of a dense, dark rock that has been identified as basalt, a type of volcanic rock that is common in the region. What is unusual, however, is the way in which the basalt blocks have been shaped and arranged. Many of the blocks have flat, smooth surfaces with edges that are cut at precise right angles, features that are not typically found in natural basalt formations, which tend to be irregular and jagged. Some of the blocks appear to have been quarried from a nearby source, then transported to the site and arranged in a deliberate pattern. The grid-like layout of the structures is particularly intriguing. It suggests a level of planning and organization that is characteristic of human settlements rather than natural geological processes. For example, the structures include large, rectangular platforms that could have served as foundations for buildings, as well as circular formations that might have been ceremonial sites or religious structures. There are also what appear to be walls and columns, which could have supported roofs or other architectural features. All of these elements combined have led many researchers to conclude that the site is not a natural formation, but rather the remains of an ancient human settlement that was once above water, but was eventually submerged by the rising Caribbean Sea. However, not all researchers are convinced that the Cuban underwater structures are man-made. A number of geologists have argued that the formations are the result of natural geological processes, such as volcanic activity, erosion, and tectonic movement. They point out that the Caribbean region is part of a tectonically active zone with a history of volcanic eruptions and earthquakes. Basalt, the rock that makes up the megaliths, is a common product of volcanic activity, and it is possible that the blocks were formed by lava flows that cooled and solidified on the sea floor. Over time, tectonic movements could have lifted the sea floor, exposing the basalt formations to erosion by waves and currents, which could have shaped them into the geometric patterns observed. Some geologists have also suggested that the grid-like pattern of the structures could be the result of fractures in the rock caused by tectonic stress, which have been further shaped by erosion. They argue that the straight lines and right angles observed in the sonar images are simply natural features that have been misinterpreted as human-made. To support their argument, these geologists point to similar natural formations found in other parts of the world, such as the Giant's Causeway in Northern Ireland, which consists of hexagonal basalt columns formed by volcanic activity, and which were once thought to be man-made. The debate between the man-made and natural origin theories has been further complicated by the fact that the Cuban underwater structures are located at a depth of 600 meters, which makes direct exploration and sampling extremely difficult. The high pressure at that depth, combined with the dark, cold water, makes it challenging for researchers to conduct detailed studies of the structures. While ROVs have been able to capture images and collect small samples of the rock, it is difficult to determine with certainty whether the rock has been modified by human hands. For example, some researchers have argued that the smooth surfaces of the basalt blocks could be the result of natural erosion rather than human polishing. Others have pointed out that the precise angles and alignment of the blocks could be the result of natural fractures rather than human cutting. To resolve this debate, more extensive sampling and analysis of the rock is needed, as well as more detailed mapping of the entire site. However, due to the logistical challenges and the high cost of deep-sea exploration, such studies have been limited. As a result, the origin of the Cuban underwater structures remains a matter of intense debate. Despite the challenges, a number of researchers have conducted detailed analyses of the available data in an attempt to determine whether the structures are man-made or natural. One of the key pieces of evidence cited by those who support the man-made theory is the presence of tool marks on some of the basalt blocks. In 2001, the ADC team released images taken by the ROV that appeared to show grooves and scratches on the surface of the blocks, which they argued were the result of human tools used to shape the rock. They also noted that some of the blocks had been cut into precise shapes, with flat surfaces and right angles, which would have required advanced tools and techniques for their creation. However, geologists who support the natural origin theory have argued that these marks could be the result of natural processes, such as the scraping of icebergs or the movement of sediment and debris across the sea floor. They point out that the grooves and scratches observed in the images are consistent with the type of marks left by natural erosion, rather than human tools. Another piece of evidence cited by the man-made theory supporters is the grid-like layout of the structures, which they argue is too regular to be the result of natural processes. They note that the structures are arranged in straight lines, with equal distances between them, which suggests a level of planning and organization that is characteristic of human settlements. However, geologists have countered that such grid-like patterns can also be formed by natural processes, such as the movement of tectonic plates or the formation of fault lines, which can create regular, linear features on the seafloor. To further complicate the debate, there is no clear evidence of human activity associated with the underwater structures, such as pottery, tools, or human remains. If the site were once a human settlement, one would expect to find artifacts that indicate human occupation, such as broken pottery shards, stone tools, or even skeletal remains. However, despite multiple expeditions to the site, no such artifacts have been found. This lack of evidence has led some researchers to question the man-made theory, arguing that if the structures were built by humans, there should be some trace of their presence. Supporters of the man-made theory, however, argue that the artifacts may have been lost or destroyed over time due to the effects of the ocean environment. They note that the site has been submerged for thousands of years, and that saltwater, currents, and marine life could have eroded or destroyed any artifacts that were once present. They also suggest that the artifacts may be buried beneath the sediment of the sea floor, making them difficult to detect with current technology. Another possibility is that the site was a ceremonial center rather than a permanent settlement, which would explain the lack of everyday artifacts. Ceremonial sites often have few artifacts, as they are used for religious or ritual purposes rather than for daily living. In addition to the debate over the origin of the structures, there is also much speculation about the civilization that could have built them, if they are indeed man-made. If the Cuban underwater structures are the remains of an ancient city, then it would suggest the existence of a previously unknown advanced civilization that thrived in the Caribbean region thousands of years ago. This civilization would have had to possess advanced engineering skills, including the ability to quarry, transport, and shape large blocks of basalt, as well as the knowledge to design and build a complex grid-like settlement. Such a civilization would have been comparable in sophistication to other ancient civilizations, such as the Maya, Aztec, or Inca, which built impressive structures in Central and South America. However, unlike these civilizations, which left behind extensive archaeological evidence, the supposed Caribbean civilization has left no other traces of its existence. This has led some researchers to speculate that the civilization was relatively small, or that it existed for a short period of time before being submerged by rising sea levels. Others have suggested that the civilization may have been part of a larger network of ancient cultures that spread across the Caribbean and Central America, but whose history has been lost to time. One of the most intriguing theories about the Cuban underwater structures is that they are the remains of the legendary lost continent of Atlantis. The story of Atlantis, a powerful and advanced civilization that that was said to have sunk into the ocean in a single day and night has captivated people for centuries. First described by the ancient Greek philosopher Plato in his dialogues Timaeus and Critias, Atlantis was said to be a large island located beyond the Pillars of Hercules, now the Strait of Gibraltar, with a powerful navy and a sophisticated society. While most historians and archaeologists consider Atlantis to be a myth, some people have suggested that the Cuban underwater structures could be the remains of this legendary continent. Proponents of this theory point to the grid-like layout of the structures, which they argue matches Plato's description of Atlantis as a city with a grid of streets and buildings. They also note that the location of the structures, off the coast of Cuba, is consistent with some interpretations of Plato's description of Atlantis' location. However, there is no scientific evidence to support this theory, and most researchers dismiss it as a matter of speculation rather than fact. Plato's account of Atlantis is widely believed to be a myth or an allegory rather than a historical account, and there is no evidence to link the Cuban underwater structures to the legendary continent. Another theory about the Cuban underwater structures is that they were built by the Taino people, an indigenous group that inhabited the Caribbean islands before the arrival of Christopher Columbus. The Taino were a sophisticated society with a complex culture, known for their agriculture, pottery, and stone carvings. They built large ceremonial centers and settlements across the Caribbean, and it is possible that they could have built the underwater structures. However, there is no evidence to link the Taino to the site. The Taino were primarily a coastal people, and their settlements were typically located on land, near the shore. They did not have the technology to quarry and transport large blocks of basalt to a site 600 meters underwater, nor did they have the engineering skills to build such complex structures. Additionally, the Taino left behind extensive archaeological evidence of their settlements, including pottery, tools, and stone carvings. But none of these artifacts have been found at the underwater site. For these reasons, most researchers do not believe that the Taino built the Cuban underwater structures. A more plausible theory is that the underwater structures were built by a pre-Taino civilization, which existed in the Caribbean region thousands of years before the Taino. Little is known about the pre-Taino peoples of the Caribbean, as they left behind few archaeological remains. However, recent archaeological discoveries have suggested that the Caribbean was inhabited by humans as early as 7,000 years ago, and that these early peoples may have had more advanced skills than previously thought. For example, in 2018, archaeologists discovered the remains of a pre-Taino settlement in the Dominican Republic, which included stone tools and pottery that were more sophisticated than previously believed. This suggests that there may have been advanced civilizations in the Caribbean before the Taino, which could have built the Cuban underwater structures. If this is the case, then the underwater site could be a key piece of evidence in understanding the early history of the Caribbean and the development of human civilization in the region. However, without more evidence, this theory remains speculative. To better understand the Cuban underwater structures, it is important to consider the geological history of the Caribbean region. The Caribbean Sea is part of the Caribbean Plate, which is surrounded by tectonic boundaries. The region has a long history of volcanic activity, with numerous volcanoes located on the islands and beneath the sea. The Guanahacabibes Peninsula, where the underwater structures are located, is part of a volcanic zone that has been active for millions of years. This volcanic activity has resulted in the formation of large amounts of basalt, which is the rock that makes up the underwater megaliths. Over time, tectonic movements have caused the sea floor to rise and fall, and changes in sea level have submerged and exposed coastal areas. During the last ice age, which ended approximately 11,700 years ago, sea levels were much lower than they are today, and many areas that are now underwater were above water. It is possible that the Cuban underwater structures were built during this period, when the site was a coastal area, and were later submerged as sea levels rose. This would explain why the structures are now underwater, and why there is no evidence of human activity on the surface of the sea floor. Any artifacts or remains would have been covered by sediment or destroyed by the ocean environment. The rise in sea levels at the end of the Ice Age is a key factor in understanding the Cuban underwater structures. During the Ice Age, large amounts of water were locked up in glaciers, causing sea levels to drop by as much as 120 meters, 394 feet below their current levels. This exposed vast areas of land that are now underwater, including parts of the Caribbean sea floor. As the glaciers melted, sea levels began to rise, submerging these areas over a period of several thousand years. If the Cuban underwater structures were built during the Ice Age, when the site was above water, they would have been submerged gradually as sea levels rose. This gradual submergence would have allowed the structures to remain relatively intact, as they were not subjected to the sudden force of a flood or tsunami. The grid-like layout of the structures suggests that they were built by a civilization that had a sophisticated understanding of urban planning, and that they were used for a specific purpose, such as a city, a ceremonial center, or a port. The fact that the structures are located at a depth of 600 meters suggests that they were submerged over a long period of time as sea levels rose gradually. In addition to the geological history of the region, it is also important to consider the oceanographic conditions that have affected the Cuban underwater structures. The Caribbean Sea is known for its clear, warm waters, which have allowed the structures to be preserved relatively well. The low levels of sedimentation in the area have also helped to preserve the structures, as they have not been buried under large amounts of mud or sand. However, the ocean environment has also caused some damage to the structures over time. Saltwater corrosion, wave action, and marine life have eroded the surface of the basalt blocks, making it difficult to determine whether they were shaped by humans or by natural processes. Marine organisms, such as coral and algae, have also colonized the structures, covering parts of them and making it difficult to see their original features. Despite these challenges, the structures remain relatively intact, providing researchers with a unique opportunity to study them and determine their origin. Over the years, a number of expeditions have been conducted to study the Cuban underwater structures, each using more advanced technology than the previous one. In 2003, the ADC team returned to the site with a more advanced ROV, which was able to capture high-definition images of the structures and collect more detailed samples of the rock. The team also used a submersible vehicle to carry researchers down to the site, allowing them to observe the structures firsthand. During this expedition, the team discovered additional structures that had not been detected in the initial sonar mapping, including what appeared to be a large, circular platform that could have been a ceremonial site. The team also collected samples of the basalt blocks, which were analyzed in a laboratory to determine their age and composition. The results of the analysis showed that the basalt was approximately 8,000 years old, which is consistent with the time period when the site would have been above water during the Ice Age. This finding supports the theory that the structures were built by humans during this period, as it would have been possible for a civilization to exist in the area at that time. In 2005, another expedition was conducted by a team of researchers from the University of Havana and the Cuban Academy of Sciences. This team used side-scan sonar and ROVs to map the site in even greater detail, and they also conducted geophysical surveys to determine the structure of the sea floor beneath the megaliths. The results of the geophysical surveys showed that the structures were built on a solid bedrock foundation, which suggests that they were intentionally constructed in that location. The team also found evidence of what appeared to be quarries located near the site, which could have been the source of the basalt blocks used to build the structures. This finding supports the man-made theory, as it suggests that the blocks were quarried and transported to the site, rather than being formed naturally in place. The team also discovered that the structures were aligned with the cardinal directions: north, south, east, west, which is a common feature of ancient human settlements and ceremonial sites. This alignment suggests that the builders of the structures had a sophisticated understanding of astronomy and geography, which further supports the idea that they were an advanced civilization. Despite these findings, there are still many researchers who remain skeptical about the man-made origin of the Cuban underwater structures. In 2008, a team of geologists from the University of Miami conducted a detailed study of the site, using advanced imaging technology and rock sampling. The team concluded that the structures were the result of natural geological processes, specifically the formation of basalt columns by volcanic activity, followed by erosion and tectonic movement. They argued that the grid-like pattern of the structures was the result of fractures in the basalt caused by tectonic stress, and that the smooth surfaces of the blocks were the result of erosion by waves and currents. The team also noted that the age of the basalt, 8,000 years, was consistent with the age of other volcanic formations in the region, and that there was no evidence of human modification of the rock. This study reignited the debate over the origin of the structures, with both sides presenting compelling evidence to support their theories. One of the key challenges in resolving the debate is the lack of direct evidence of human activity at the site. While the grid-like layout and precise alignment of the structures suggest human intervention, there is no concrete evidence, such as tools, pottery, or human remains, to confirm this. Without such evidence, it is difficult to definitively prove that the structures are man-made. However, it is also important to consider that the site has been submerged for thousands of years, and that any evidence of human activity may have been lost or destroyed. For example, organic materials, such as wood or cloth, would have decomposed over time, and stone tools or pottery may have been buried beneath sediment or broken into small pieces that are difficult to detect. Additionally, the high pressure and cold water at 600 meters depth may have accelerated the decomposition of any organic artifacts, making them impossible to find. Another challenge is the difficulty of conducting research at such depths. Deep-sea exploration is expensive and logistically challenging, requiring specialized equipment and trained personnel. As a result, only a limited number of expeditions have been able to study the Cuban underwater structures in detail. Each expedition has provided new information, but there is still much that is unknown about the site. For example, the full extent of the structures has not yet been mapped, and it is possible that there are additional formations that have not yet been discovered. Additionally, more detailed analysis of the rock samples is needed to determine whether they were shaped by human tools or by natural processes. This would require collecting more samples and using advanced laboratory techniques, such as electron microscopy, to examine the surface of the rock for tool marks. Despite these challenges, the Cuban underwater structures continue to fascinate researchers and the public alike. They represent a mystery that has the potential to rewrite our understanding of ancient human civilizations and their capabilities. If the structures are man-made, they would provide evidence of a previously unknown advanced civilization in the Caribbean region, which existed thousands of years ago and had the skills to build complex megalithic structures. This would challenge the traditional view that the ancient civilizations of the Americas were limited to Central and South America, and would suggest that the Caribbean was also a center of human innovation and development. On the other hand, if the structures are natural, they would provide valuable insights into the geological processes that have shaped the Caribbean sea floor over millions of years, and would help scientists better understand the region's tectonic and volcanic history. In addition to their scientific significance, the Cuban underwater structures also have cultural and historical importance. For the people of Cuba, the structures are a source of national pride and curiosity, representing a unique part of the country's history and heritage. They have also become a popular tourist attraction, with many people traveling to Cuba to learn more about the mystery of the sunken megaliths. The Cuban government has recognized the importance of the site and has taken steps to protect it from damage, including restricting access to the area and supporting scientific research. In 2010, the Cuban government declared the area a protected marine reserve in order to preserve the structures and the surrounding marine ecosystem. This designation ensures that the site will be protected for future generations, and that researchers will have the opportunity to continue studying it. The Cuban underwater structures also have implications for our understanding of climate change and sea level rise. If the structures were built during the Ice Age and submerged as sea levels rose, they provide a tangible example of how climate change can affect human civilizations. In today's world, as global temperatures rise and sea levels continue to increase, the story of the Cuban underwater structures serves as a warning about the potential impact of climate change on coastal communities. It reminds us that even the most advanced civilizations can be vulnerable to the forces of nature, and that we must take action to address climate change in order to protect our own communities and heritage. As research into the Cuban underwater structures continues, it is likely that new discoveries will be made that will help to resolve the debate over their origin. Advances in technology, such as more advanced ROVs, submersibles, and laboratory techniques, will allow researchers to study the site in greater detail and to collect more evidence to support their theories. It is also possible that additional underwater sites will be discovered in the Caribbean region, which could provide further clues about the existence of ancient civilizations. For example, in recent years, researchers have discovered other underwater structures off the coasts of Mexico, Belize, and the Dominican Republic, which have also sparked debate about their origin. These discoveries suggest that the Caribbean Sea may be home to many more sunken megaliths, which could rewrite the history of the region. In conclusion, the Cuban underwater structures are one of the most intriguing mysteries of the Caribbean Sea. They are a complex network of megalithic formations that have sparked intense debate among scientists, archaeologists, and explorers. While some researchers believe that they are the remains of an ancient, advanced civilization that was submerged by rising sea levels, others argue that they are simply natural geological formations shaped by volcanic activity and erosion. The truth about their origin remains elusive, but ongoing research and exploration are bringing us closer to uncovering the secrets of these sunken megaliths. Whether they are man-made or natural, the Cuban underwater structures are a testament to the power of nature and the ingenuity of human civilizations. They remind us that there is still much to learn about our planet's history, and that the depths of the ocean hold many secrets waiting to be discovered. As we continue to explore the Caribbean Sea and other parts of the world's oceans, we may yet find more evidence that will help us to understand the true nature of the Cuban underwater structures and to rewrite the history of human civilization in the Americas, to further elaborate on the scientific evidence surrounding the Cuban underwater structures. It is essential to delve into the geological and archaeological analyses that have been conducted over the past 2 decades. The initial sonar mapping conducted by Zelitsky and her team in 2000 provided the first glimpse of the structures, revealing a series of linear and rectangular features that were inconsistent with the surrounding sea floor. The sonar images showed that the structures were composed of dense, dark rock, which was later identified as basalt through sample analysis. Basalt is a fine-grained volcanic rock that forms when lava cools quickly, and it is commonly found in the Caribbean region due to the area's volcanic activity. However, the way in which the basalt blocks were arranged, with straight lines, right angles, and a grid-like pattern, was what caught the researchers' attention, as natural basalt formations tend to be irregular and random. In 2001, the team returned to the site with an ROV equipped with high-resolution cameras, which allowed them to capture detailed images of the structures. The ROV footage revealed that many of the basalt blocks had flat, smooth surfaces, with edges that were cut at precise 90-degree angles. Some of the blocks appeared to be stacked on top of each other, forming walls or columns, while others were arranged in circular patterns. The team also observed what appeared to be channels or pathways between the structures, which were approximately 2 meters, 6.6 feet wide, and 1 meter, 3.3 feet deep. These channels were straight and evenly spaced, suggesting that they were intentionally constructed, possibly for transportation or drainage. The team also noted that the structures were aligned with the cardinal directions, which is a common feature of ancient human settlements, as it allows for precise astronomical observations and planning to determine the age of the structures. The team collected samples of the basalt blocks and conducted radiometric dating. Radiometric dating is a scientific technique that uses the decay of radioactive isotopes to determine the age of rocks and other materials. The results of the dating showed that the basalt was approximately 8,000 years old, which places it in the late Pleistocene epoch, a time when the last ice age was coming to an end. During this period, sea levels were much lower than they are today, and the area where the structures are located would have been a coastal plain above water. This suggests that the structures could have been built by humans during this period, when the site was accessible and habitable. However, geologists who support the natural origin theory have challenged these findings. They argue that the radiometric dating only tells us the age of the basalt, not the age of the structures themselves. The basalt could have been formed by volcanic activity 8,000 years ago, but the structures could have been formed much later by natural processes. They also point out that the smooth surfaces and right angles of the blocks could be the result of erosion by waves and currents, which can shape rock into regular patterns over time. For example, in coastal areas, waves can erode rock into flat, smooth surfaces, and tectonic stress can cause rock to fracture into straight lines and right angles. The grid-like pattern of the structures, they argue, could be the result of a series of parallel fault lines, which have been further shaped by erosion. Another point of contention is the presence of tool marks on the basalt blocks. The ADC team claimed that the ROV footage showed grooves and scratches on the surface of the blocks, which they interpreted as tool marks made by humans. However, geologists have argued that these marks could be the result of natural processes, such as the scraping of icebergs during the Ice Age, or the movement of sediment and debris across the sea floor. They note that the marks are inconsistent with the type of tool marks left by ancient human tools, which tend to be more uniform and precise. Additionally, they point out that there is no evidence of the tools themselves, such as chisels or hammers, which would have been used to shape the basalt blocks. To resolve this debate, more detailed analysis of the tool marks is needed. In 2012, a team of archaeologists and geologists from the University of Florida conducted a detailed study of the ROV footage, using advanced image analysis techniques to examine the grooves and scratches on the basalt blocks. The team concluded that the marks were inconsistent with natural erosion, and that they were more likely the result of human tools. They noted that the marks were uniform in depth and width, and that they were concentrated in specific areas of the blocks, which is consistent with human activity. However, the team also acknowledged that more direct evidence, such as the discovery of tools or artifacts, would be needed to confirm this conclusion. Another important piece of evidence is the presence of quarries near the site. In 2005, the Cuban research team discovered a series of depressions in the sea floor, approximately 1 kilometer, 0.62 miles, from the underwater structures, which they identified as quarries. The depressions were filled with basalt fragments, and the walls of the depressions showed signs of being cut and shaped. The team argued that these quarries were the source of the basalt blocks used to build the structures, and that the blocks were transported to the site via the channels that were observed between the structures. This finding supports the man-made theory, as it suggests that the builders of the structures had the ability to quarry and transport large blocks of basalt, which would have required advanced engineering skills. However, geologists have countered that the depressions could be natural features, such as volcanic craters or sinkholes, rather than quarries. They note that the Caribbean region is prone to volcanic activity, and that the depressions could have been formed by volcanic eruptions or the collapse of underground cavities. They also point out that the basalt fragments in the depressions could be the result of natural erosion, rather than human quarrying. To resolve this, the team would need to collect samples from the walls of the depressions to determine whether they show signs of human modification, such as tool marks or cut surfaces. In addition to the geological and archaeological evidence, there is also anecdotal evidence that supports the man-made theory. Local fishermen in the area have reported seeing unusual structures beneath the water for decades, long before the official discovery in 2000. Some fishermen have described seeing large, flat rocks arranged in a grid pattern, and have reported that their nets often get caught on the structures. While this anecdotal evidence is not scientific, it suggests that the structures have been present for a long time, and that they are not a recent natural formation. Another piece of anecdotal evidence comes from the indigenous people of Cuba, who have oral traditions that speak of a lost city that was submerged by the sea. The Taino people, who inhabited Cuba before the arrival of Columbus, have stories of a great city called Zamna, which was said to be located on the northern coast of Cuba and was submerged by a great flood. While there is no direct evidence to link these stories to the Cuban underwater structures, they provide an interesting cultural context for the mystery. The oral traditions suggest that the indigenous people of Cuba were aware of a sunken city, which could be the underwater structures discovered in 2000. Despite the ongoing debate, there is one thing that all researchers agree on. The Cuban underwater structures are a unique and important natural or cultural feature. Whether they are man-made or natural, they provide valuable insights into the history of the Caribbean region. If they are man-made, they represent a previously unknown advanced civilization that thrived in the Caribbean thousands of years ago, and they could rewrite our understanding of human development in the Americas. If they are natural, they provide a fascinating example of how geological processes can shape the sea floor into complex, geometric patterns, and they help us to better understand the volcanic and tectonic history of the Caribbean. To further advance our understanding of the Cuban underwater structures, it is essential that more research is conducted. This research should include more detailed mapping of the site, using advanced sonar and imaging technology to determine the full extent of the structures. It should also include more extensive sampling of the basalt blocks and the surrounding seafloor to determine whether the blocks were shaped by humans or by natural processes. Additionally, researchers should conduct geophysical surveys to determine the structure of the seafloor beneath the structures, and to look for evidence of human activity, such as buried artifacts or foundations. Another important area of research is the study of other underwater structures in the Caribbean region. In recent years, researchers have discovered similar structures off the coast of Mexico, Belize, and the Dominican Republic. For example, off the coast of Belize, researchers have discovered a series of underwater stone structures that appear to be man-made, including walls, columns, and platforms. These structures are similar in size and shape to the Cuban underwater structures, and they may be part of a larger network of ancient settlements in the Caribbean. By studying these structures, researchers can compare them to the Cuban underwater structures and look for patterns that may indicate a common origin or civilization. In addition to scientific research, it is also important to involve local communities in the study of the Cuban underwater structures. The people of Cuba, particularly those who live near the Guanahacabibes Peninsula, have a unique connection to the site, and their knowledge and traditions could provide valuable insights into its history. By working with local fishermen, indigenous communities, and other local residents, researchers can gather anecdotal evidence and cultural context that may help to resolve the debate over the origin of the structures. The Cuban underwater structures are a reminder of how much we still have to learn about our planet's history. They are a mystery that has captivated the world, and they continue to inspire researchers to explore the depths of the Caribbean Sea in search of answers. Whether they are the remains of a lost civilization or a natural geological wonder, they are a testament to the power and beauty of nature and to the ingenuity of human beings. As we continue to study and explore these sunken megaliths, we may yet uncover the truth about their origin, and in doing so, rewrite the history of the Caribbean and the Americas. In recent years, advances in technology have opened up new possibilities for studying the Cuban underwater structures. For example, the use of autonomous underwater vehicles, AUVs, has allowed researchers to map the site in greater detail without the need for a human operator. AUVs are equipped with sonar, cameras, and other sensors, and they can navigate the sea floor independently, collecting data and images that would be difficult or impossible to obtain with traditional ROVs. This technology has allowed researchers to map the entire site more accurately and to discover new structures that were previously hidden from view. Another technological advancement that has been useful in studying the Cuban underwater structures is 3D modeling. Using the data collected from sonar and ROV images, researchers can create detailed 3D models of the structures, which allow them to examine the features of the megaliths from all angles. These 3D models can be used to identify patterns and features that are not visible in 2D images, and they can help researchers to determine whether the structures were built by humans or by natural processes. For example, 3D models can reveal the precise angles and dimensions of the blocks, which can be compared to the angles and dimensions of known human-made structures. In addition to 3D modeling, researchers have also used advanced laboratory techniques to analyze the basalt samples collected from the site. For example, electron microscopy has been used to examine the surface of the basalt blocks at a microscopic level, looking for evidence of tool marks or human modification. This technique has revealed that some of the blocks have smooth surfaces that are consistent with human polishing, while others have irregular surfaces that are consistent with natural erosion. However, the results of these analyses have been inconclusive, and more research is needed to determine whether the smooth surfaces are the result of human activity or natural processes. One of the most promising areas of research is the use of DNA analysis to look for evidence of human activity at the site. While DNA is typically associated with living organisms, it can also be preserved in the environment, such as in sediment or on rock surfaces. Researchers are currently exploring the possibility of extracting DNA from the sediment surrounding the underwater structures to see if there are any traces of human DNA that could indicate that the site was once inhabited. If human DNA is found, it would provide strong evidence that the structures are man-made. However, extracting DNA from deep-sea sediment is challenging, and the results are not yet available. Another area of research is the study of the marine life that has colonized the underwater structures. The structures provide a habitat for a variety of marine organisms, including coral, algae, and fish. By studying these organisms, researchers can determine how long the structures have been submerged and how they have been affected by the ocean environment over time. For example, the growth rate of coral can be used to estimate the age of the structures. As coral grows at a relatively constant rate, this information can help to confirm the age of the structures and to determine whether they were submerged gradually or suddenly. Despite the progress that has been made in studying the Cuban underwater structures, there are still many unanswered questions. For example, if the structures are man-made, who built them? What was their purpose? How did the builders obtain the technology and skills needed to quarry and transport large blocks of basalt? And why did the civilization that built them disappear? These questions may never be fully answered, but ongoing research and exploration are bringing us closer to understanding the mystery of the sunken megaliths. In conclusion, the Cuban underwater structures are a fascinating and enigmatic feature of the Caribbean Sea. They have sparked intense debate among scientists and researchers, and they continue to inspire new discoveries and theories. Whether they are the remains of an ancient civilization or a natural geological formation, they provide valuable insights into the history of the Caribbean region. As technology advances and research continues, we may yet uncover the truth about these sunken megaliths, and in doing so, gain a deeper understanding of our planet's past and the role of human civilizations in shaping it. The Cuban underwater structures are a reminder that the ocean holds many secrets, and that there is still much to learn about the world we live in. To expand further on the cultural and historical implications of the Cuban underwater structures, it is important to consider their place in the broader context of ancient civilizations in the Americas. For centuries, historians and archaeologists have focused on the great civilizations of Central and South America, such as the Maya, Aztec, and Inca, which built impressive cities, pyramids, and other structures. However, the Cuban underwater structures suggest that there may have been other advanced civilizations in the Caribbean region that have been overlooked by history. If these structures are man-made, they would indicate that the Caribbean was not a backwater, but rather a center of human innovation and development, with civilizations that were capable of building complex megalithic structures. The existence of such a civilization would also challenge our understanding of the peopling of the Americas. Traditional theories suggest that the first humans arrived in the Americas via the Bering Land Bridge, which connected Asia and North America during the Ice Age. These early humans then spread southward, eventually reaching Central and South America. However, the Cuban underwater structures, if they are 8,000 years old, would suggest that there were advanced civilizations in the Caribbean at a time when the peopling of the Americas was still in its early stages. This would imply that the Caribbean was settled much earlier than previously thought, and that the early inhabitants of the region had a level of sophistication that was not previously attributed to them. Another cultural implication of the Cuban underwater structures is their potential connection to other ancient civilizations around the world. The megalithic structures found in Cuba are similar in size and shape to megaliths found in other parts of the world, such as Stonehenge in England, the pyramids of Egypt, and the megaliths of Easter Island. This similarity has led some researchers to speculate that there may have been a global network of ancient civilizations that shared knowledge and technology, allowing them to build similar structures. While this theory is highly speculative, it is an intriguing possibility that could rewrite our understanding of human history. In addition to their cultural and historical implications, the Cuban underwater structures also have economic implications for Cuba. The site has become a popular tourist attraction, drawing visitors from around the world who are interested in the mystery of the sunken megaliths. This tourism has the potential to boost the Cuban economy, creating jobs and generating revenue for local communities. The Cuban government has recognized this potential and has taken steps to promote the site as a tourist destination while also protecting it from damage. For example, the government has established guided tour of the area, using glass-bottom boats to allow visitors to see the structures without damaging them. This balance between tourism and conservation is essential to ensuring that the site is preserved for future generations. The Cuban underwater structures also have implications for marine conservation. The site is located in a protected marine reserve, which is home to a variety of marine life, including coral reefs, fish, and other aquatic organisms. The structures themselves provide a habitat for these organisms, and their preservation is essential to maintaining the health of the marine ecosystem. By protecting the underwater structures, the Cuban government is also protecting the surrounding marine life, which is important for the overall health of the Caribbean Sea. In conclusion, the Cuban underwater structures are a complex and fascinating mystery that has captured the imagination of people around the world. They are a testament to the power of nature and the ingenuity of human beings, and they have the potential to rewrite our understanding of ancient civilizations and the history of the Americas. While the debate over their origin continues, ongoing research and exploration are bringing us closer to uncovering the truth about these sunken megaliths. Whether they are man-made or natural, they are a valuable part of our planet's heritage, and they deserve to be protected and studied for generations to come. As we look to the future, it is likely that the Cuban underwater structures will continue to be a focus of scientific research and public interest. Advances in technology will allow researchers to study the site in greater detail, and new discoveries will be made that will help to resolve the debate over their origin. In the meantime, the mystery of the sunken megaliths will continue to inspire curiosity and wonder, reminding us of the many secrets that the ocean holds. Whether we are scientists, explorers, or simply curious individuals, the Cuban underwater structures invite us to explore the unknown, to question our assumptions, and to embrace the mystery of our planet's past. To further enhance our understanding of the Cuban underwater structures, it is crucial to consider the perspectives of different disciplines, including geology, archaeology, oceanography, and anthropology. Each discipline brings a unique set of tools and insights to the table, and by combining these perspectives, we can gain a more comprehensive understanding of the site. For example, geologists can help us to understand the geological processes that shaped the structures. Archaeologists can help us to determine whether they are man-made. Oceanographers can help us to understand the oceanographic conditions that have preserved the structures. And anthropologists can help us to interpret the cultural and historical context of the site. Geologists play a key role in studying the Cuban underwater structures, as they can help to determine whether the formations are natural or man-made. By analyzing the composition and structure of the basalt blocks, geologists can determine how they were formed and whether they were shaped by volcanic activity, erosion, or human intervention. They can also use geophysical techniques to study the seafloor beneath the structures, to determine whether there are any underlying geological features that could have influenced their formation. For example, geologists can use seismic surveys to map the subsurface structure of the seafloor to see if there are any fault lines or volcanic features that could have caused the formation of the grid-like pattern. Archaeologists, on the other hand, focus on the human aspect of the site. They look for evidence of human activity, such as tool marks, artifacts, and human remains, to determine whether the structures were built by humans. They also study the layout and design of the structures to see if they are consistent with known human settlements or ceremonial sites. For example, archaeologists can compare the grid-like layout of the Cuban underwater structures to the layout of other ancient cities, such as the Maya city of Teotihuacan, which was also arranged in a grid pattern. This comparison can help to determine whether the Cuban structures were built by a civilization with similar urban planning skills. Oceanographers play an important role in studying the Cuban underwater structures by examining the oceanographic conditions that have preserved the site. They study the water temperature, salinity, and current patterns in the area to determine how they have affected the preservation of the structures. They also study the sedimentation rates in the area to determine how much sediment has accumulated on the sea floor over time, and how this has affected the visibility and preservation of the structures. For example, oceanographers can use sediment cores to determine the rate at which sediment has accumulated, and to see if there are any layers of sediment that indicate a sudden change in the environment, such as a flood or a tsunami. Anthropologists focus on the cultural and historical context of the site by studying the oral traditions and cultural practices of the indigenous people of Cuba. They look for connections between the underwater structures and the cultural beliefs of the Taino and other indigenous groups to see if there is any evidence that the structures were part of their cultural heritage. For example, anthropologists can study the oral traditions of the Taino people, which speak of a lost city submerged by the sea, and compare these stories to the features of the Cuban underwater structures. This comparison can help to determine whether the structures were part of the Taino culture or part of a pre-Taino civilization. By combining the perspectives of these different disciplines, researchers can gain a more comprehensive understanding of the Cuban underwater structures. This interdisciplinary approach is essential to resolving the debate over their origin and to uncovering the secrets of these sunken megaliths. It also allows researchers to address the broader questions that the structures raise, such as the development of ancient civilizations in the Caribbean, the impact of climate change on human societies, and the role of the ocean in preserving our planet's history. In addition to the interdisciplinary approach, it is also important to foster international collaboration in the study of the Cuban underwater structures. The site is located in Cuban waters, but it is of global significance, and researchers from around the world have an interest in studying it. By collaborating with researchers from other countries, the Cuban government can access advanced technology and expertise that may not be available in Cuba, and can share its own knowledge and findings with the international community. This collaboration can help to accelerate research and to ensure that the site is studied in a comprehensive and objective manner. International collaboration is also important for the conservation of the Cuban underwater structures. The site is a unique and fragile ecosystem, and it is vulnerable to damage from human activity, such as fishing, tourism, and pollution. by working with international organizations such as the United Nations Educational, Scientific, and Cultural Organization, UNESCO. The Cuban government can develop effective conservation strategies to protect the site. UNESCO has a program dedicated to the protection of underwater cultural heritage, and it can provide technical and financial support to Cuba to help preserve the underwater structures. In conclusion, the Cuban underwater structures are a unique and important feature of our planet's heritage. They are a mystery that has captivated the world, and they continue to inspire research and exploration. By combining the perspectives of different disciplines and fostering international collaboration, we can gain a more comprehensive understanding of the site and can work together to protect it for future generations. Whether the structures are man-made or natural, they are a testament to the power of nature and the ingenuity of human beings, and they remind us of the many secrets that the ocean holds. As we continue to study and explore these sunken megaliths, we may yet uncover the truth about their origin, and in doing so, gain a deeper understanding of our planet's past and the role of human civilizations in shaping it. To summarize, the Cuban underwater structures are a complex network of megalithic formations located off the northern coast of Cuba at a depth of approximately 600 meters. Discovered in 2000 by a team of Canadian and Cuban researchers, the structures have sparked intense debate over their origin, with some researchers arguing that they are the remains of an ancient human civilization, and others arguing that they are natural geological formations. The key evidence supporting the man-made theory includes the grid-like layout of the structures, the precise angles and smooth surfaces of the basalt blocks, the presence of quarries near the site, and the alignment of the structures with the cardinal directions. The key evidence supporting the natural origin theory includes the volcanic history of the region, the lack of human artifacts at the site, and the similarity of the structures to natural geological formations found in other parts of the world. Despite the ongoing debate, the Cuban underwater structures are a valuable part of our planet's heritage, and they provide important insights into the geological and cultural history of the Caribbean region. They are a reminder of the power of nature and the ingenuity of human beings, and they continue to inspire research and exploration. As technology advances and research continues, we may yet uncover the truth about these sunken megaliths, and in doing so, rewrite the history of the Caribbean and the Americas. The Cuban underwater structures are a testament to the fact that there is still much to learn about our planet's past, and that the ocean holds many secrets waiting to be discovered.